So first thing we got to know is, what is a taper? So a taper is a uniform change in diameter. Okay, so we could have um, a piece of bar stock, and we can put it up on a lathe, and we can taper this and turn it into a cone essentially, right? So if I were to kind of look at this isometrically, right, it would kind of look like this. If I was standing it up on a table, if I were to create a taper on this part, right? If I were to change this into this, then this would kind of look like this by the time I was finished with it, right? So the taper, two-dimensionally, would kind of look like this, right? A triangle with the end cut off, and it would look like a cone, right? In an isometric view. So what we want to do is we want to know how to cut tapers, because it's actually very, very common in machining to cut a taper. So it can be a taper that has to meet a call out on a print. A lot of times tapers are used for fits and holding. We can use tapers to lock parts together. And sometimes we just create a taper on the side of a part, just to on the corner of a part, just to provide a chamfer around the outside diameter of a part. So a chamfer around the end, when you face a part on the lathe and then you chamfer the edge so it's not sharp anymore, that's just a really, really small taper, right? So it's a very short, steep taper. So we need to know how to create tapers. So there's three ways, primarily three ways that we can cut a taper on a lathe, but only two of them are commonly used. So the least common and hardly ever used is by means of a taper attachment. Now, how the taper attachment works is the carriage is actually connected to by means of bolts, and an arm is connected to a taper attachment. And that taper attachment, what it basically does is it follows a pattern, and it literally just traces and pulls the carriage the direction as it follows the taper that's attached to the lathe. So that's not a very common way of cutting tapers. If we need to cut accurate tapers that require that type of setup, odds are we're going to use a CNC lathe, or we subcontract it out. Probably costs just as much. But the two common ways on a manual lathe that we'll set up and cut a taper, one is with the tailstock offset, which we've touched on a little bit, and that's where we loosen the bolts holding the upper casting to the lower casting on the tailstock, so that we can move the upper casting away from us or towards us. Now, that's not towards the spindle, that's perpendicular to the spindle, right? But if you've looked at a manual lathe, there's not a lot of movement there. It's very limited. But there's the longer the part is, if we have a part in between the center of the spindle and the center of the tailstock, a small movement on the tailstock can create a pretty big taper depending on the length of that part, right? So tailstock offset is usually used when a taper has to be created on the entire length of a part, or if we want to create a shallow taper over a longer length, okay? The other way we cut tapers on a manual lathe is by means of the compound rest, where we can swivel the compound rest into a position or into an angle, and then use the compound rest hand wheel to cut the taper, because that hand wheel follows the compound rest. No matter which way I adjust that compound rest, the handle follows it, right? So as soon as I lock that compound rest into position, I wind that handle, it'll wind on whatever angle I'm set on. So a compound rest setup excuse me. So using the compound rest to cut a taper, it's to cut short, steep tapers. So you can imagine there's not a lot of stroke on that little compound rest, right? So we kind of have those two options. Longer, shallower tapers will be with the tailstock offset, and shorter and steeper tapers will be with the compound rest. I've mentioned that twice. I'll mention it again. It's important. You'll need to remember it, so you might want to write that down somewhere. Okay, so the first thing that we want to know about tapers is basically, how do I calculate tapers? If I need to put a taper on a part according to what a print says, how do I set that up? So, there's something to be said for standing in front of the manual lathe when we go through a lesson like this. But having the theory will help you when you get in front of that machine and you go to set it up. So the first thing that we need to learn to do any math and to do any setups is taper per foot. Okay, so when we go to set up a taper, an imperial taper, we need to be able to solve the taper per foot. So basically what that means is if my part is here, okay, you can see that one side of this is smaller in diameter than the other side. What we can see right away is, besides the fact that I can't draw with beans, okay, what we can see right away is that this part does taper. It does get smaller towards this end. So how much does this part taper over 12 inches? And that's the calculation we're looking for. So taper per foot, we'll now refer to it as our TPF, okay? Anytime we ask for TPF, that's our taper per foot. So how do we solve taper per foot? So guys, get used to practicing this formula. Use it whenever you can. And on your assignment this week, you'll have to be able to use it. So taper per foot equals okay. It's not as hard as it looks. Okay, think about what we're doing as we go through it. I need to know three things about this taper. I need to know the big D, or the large diameter. I need to know the little d, the small diameter. I need to know the LOT, the length of taper. This is just an algebraic expression, guys. Okay? We're trying to solve for this. So if we're solving for taper per foot, we need all of this information. So if we took this piece of material off of the shelf and it was a 2-inch, let's say big D equals 2 inches. And let's just make this really simple. Let's say the little d, small diameter, is 1 inch, okay? So now we have two pieces of information. TPF equals 2 minus 1. And let's say that the length of the taper, again, let's keep it simple, is 10 inches. Now, what's important to remember about length of taper, guys, it's exactly what it says. This isn't the length of the workpiece. This might be a 2-foot piece of bar stock that you put in the lathe. That's not what we're talking about. Look at the print. The print will say how long this taper needs to be. That's what this is, the length of taper, because this part could extend even further, right? So let's say the length of taper is 10. And then this is all multiplied by 12. Why is it multiplied by 12? Because this is taper per foot. Okay? All right. And there's 12 inches in a foot. So let's figure this out. 2 minus 1, let's hope that's 1, divided by 10 times 12, right? And then 1 divided by 10 is 0.1 times 12. And then up here, wow. Sorry, guys. Okay. Let's just move this up here. Okay. 0.1 times 12 is equal to 1.2. Okay. 1.2 what? What are we trying to solve? We're trying to solve how much this part tapers per foot. It's 2 inches here. It's 1 inch here. So this part tapers 1.2 inches. This part tapers 1.2 inches. Okay. So how much does it taper? Okay, so the taper per foot is 1.2. That's not how much it tapers over 10 inches, right? It's how much it tapers per foot. So make sure when you write your answers, your taper per foot is equal to 1.2 inches. Okay, it can be IN or you can just use your 2 ticks. Okay, it's how much it tapers per foot. All right. So let's just do one more example of taper per foot. Okay. Okay, let's imagine that this is a 3.5 inch diameter and this becomes a, oh, let's say 3.25 inch diameter, and we'll say that that's over 4 inches. Okay, so the part big D 3.5. Okay, so TPF, how much does it taper in 12 inches? That's 3.5 minus 3.25. Make sure you put it inside of parentheses. Divide it by the length of taper, which is 4 inches, and then multiply it by 12. Okay, so this equals 3.5 minus 3.25 is 0.25 divided by 4 times 12. Should be able to do this in my head, but I'm not going to embarrass myself. 0.25 divided by 4 is 0.0625 times 12. Therefore, the taper per foot is equal to 0.75 inches. So this taper will change, or this material will change in diameter 0.75 inches over 12 inches, right? Good. Okay. All right, let's change this up a little bit. Let's imagine for a moment that you have you've been given the taper per foot, and you need to find one of the other pieces of information. All right, so our taper per foot is 3 inches, and our large diameter let's say, is 5 inches, and our small diameter is 4.5 inches, but we don't know the length of the taper. Okay, so this is a common type of problem that we'll see in the machine shop. So how do we solve this? So when we get into algebra in math class, these are the types of questions that we're going to have to discuss. So remember, this is where technical math becomes something extremely useful for us, because we may in fact have this information, right? We may be told on the print that this is a 3-inch taper per foot, and we may be given the 2 diameters, but we may not be given the length of the taper. Now remember that the length of the taper isn't the length from this point to this point on an angle. It's a linear measurement, guys. Okay, it's the measurement here to here, not here to here. Okay, it's not the hypotenuse. Okay, it's the length of a side. So what we need to do is we need to isolate the unknown piece of information. We need to get the length of taper where the 3 is. Okay, so let's go through this together step by step so we can see how easy this is. The very first thing we want to do is we need to move the easiest part of this formula across the equal sign. Now remember what the equal sign means, right? It means that this side is equal to this side. So if I make any change on one of these sides, I have to make the exact same change on the other side, or it's no longer equal. And so if you think that way, you'll always remember how to move things around. If I change something here, I do the exact same thing here, because this has to be true all the time. Okay? So on this side, we have this numerator divided by this denominator times 12. Well, the easiest thing to move here is the 12. This side is over 12 to cancel each other out. Okay? So this side of the equal sign, divide it by 12. This side of the equal sign, divide it by 12. So this is still right. So 3 over 12 is equal to, and we can solve this, 0.5 over LOT. Okay? All right. When we get to this point in solving tapers, all we need to do is cross multiply. So what I showed you was go to the unknown piece of the fraction with the unknown information, go up to the known part, cross multiply. So 0.5 times 12. So 0.5 times 12. Okay, and then divide by 3. Okay, so if you do that in your calculators, 0.5 times 12 divided by 3 will give you 2. Okay, so we know that the length of this taper is going to be 2 inches. Now the long way to do this, and it's not much longer, if we take this fraction, 3 over 12 equals 0.5 over LOT, okay? And we actually go through the steps of cross multiplying. We do it like this. 3 times LOT is 3 times LOT is equal to 0.5 times 12, okay? 0.5 times 12. And when we cross multiply, my marker's dying here, but when we cross multiply, this is how it looks, right? So 3 times LOT, 0.5 times 12. Okay, so because we're trying to isolate the LOT, right? So 3 times LOT equals 0.5 times 12. Okay, we need to isolate the LOT. We divide this side by 3. divide this side by 3. All right, these two cancel each other out, so we end up with LOT equals 0.5 times 12 divided by 3. It's the same thing as what we just did here. Okay, what we did here is we went 0.5 times 12 divided by 3. 0.5 times 12 divide by 3. Okay, it'll work out properly. And then we know that the LOT will equal 2 inches. Okay, so for the sake of simplicity, let's do a second example of this. Okay, let's do a second example where we just show you when we don't have the denominator, all we have is the numerator. Uh, 3.25 is the big diameter. 2.25 is a small diameter. We don't have the length of taper. All right. So if you're ever unsure, basically what I just went through, you don't want to go through that and get frustrated, right? So remember this. If you don't have the denominator, then the way we're going to work it out right now is the proper way to do this. Okay, so let's simplify this first. 4 equals 1 over the length of taper times 12. Okay, we can simplify it right away. On this side, divide by 12. On this side, divide by 12. And these two cancel each other out. And what we end up with is 4 over 12 is equal to 1 over the length of taper. So we end up with what's called a proportion here, okay? So we can do it the same way we did before. 1 times 12 divided by 4, or we can work it out longhand. Okay, 1 times 12 is 12 equals 4 times LOT. Okay, 1 times 12 is 12 equals 4 times length of taper. Okay, so what we do is we divide this side by 4. We divide this side by 4, so we keep the equal sign true. These two cancel each other out. We end up with 12 over 4 is equal to the length of taper. 3 length of taper equals 3 inch. So when you are missing the denominator, you're going to wind up doing a cross multiplication. So you can either do it longhand. 1 times 12, write it down, it's 12, equals 4 times length of taper, 4 times length of taper. Okay. And then you have to, if you're doing 4 times the unknown, then divide it by 4. They cancel each other out. Just make sure you divide the other side by 4. And then you end up with your fraction. 12 over 4 equals length of taper, and then you just solve it. Sometimes what happens is we end up with missing information that is on the that is the numerator. I wonder if I deleted that. That would be crappy. Huh. I'm gonna have to find another one for you guys. That was a fun one. Let me just check here and see if I've got another one I can use with you guys. Uh, Wow. For some reason I got rid of all my hard questions. Interesting. No worries. By the time we take this up in math class, I'll have a couple of tough ones for you. All right, let's move on to our other two formulas. Okay, so we've seen how to use or how to solve taper per foot. A little bit of experience and a little bit of fun. It's always fun. You'll be able to solve missing information for cutting tapers. Now, we also have to understand the application here, guys. So you will, I'm going to make this a little nicer. You will have to cut a taper this year. You may have to cut more than one. So I really, really want you to understand how to set these up and the proper way on a machine to set these up.